Alright, welcome back to another going over. Today we're going to go over cross product. Cross product can be think of a companion of dot product. You dot two vector, you get a scalar. Now you cross two vector, you actually get a vector. But before we learn how to do cross product, it's actually important to know what a determinant is because it's the easiest way to compute a cross product. Alright, so what we'll be doing is we're going to go over how to find determinant of 3x3 matrix. Right, so computing determinant is one of those things that easier explained by example rather than going over some algorithm. But I'll list out the quick algorithm to memorize anyway, and we'll go over a quick example. So first thing you do is you're gonna repeat two columns. When you have 3x3 matrix, you're gonna have three columns. You're gonna repeat two columns again on the right, so you have 5 columns in total. Right? The second step will be multiply down minus multiply up. What do I mean by that? Let's see in action. Alright, let's find determinant of this 3x3 matrix. 1, 2, 3, 0, 1, 2, and minus 1, minus 1, 1. From the previous algorithm that I just explained, first step we're gonna do is we're gonna add 2 more columns, which is a repeat of the first 2 columns. So the first column is 1, 0, minus 1, so I'm just gonna write 1, 0, minus 1 right here. And the second column also be repeated right here, so 2, 1, minus 1. And that's the first step. The second step is to multiply down minus multiply up. So each direction we will multiply 3 times, and we're gonna multiply down diagonally. So first down gonna be, you start here and then you go down diagonally. So this is gonna be the first set of multiplication you do. Alright, so 1 times 1 times 1 gives you 1. Alright, and then you start at this number, this entry, going down diagonally. Then you multiply 3 numbers that lie along the path. So what you get in this case is 2 times 2 times minus 1, which gives you minus 4. And last but not least, we do 3, 0, minus 1. This case is 0. Alright, once you're done doing multiplication for one direction, in this case, we already finished multiplying down, right? So we get 1, minus 4, and 0. You add them together and call that down. In this case, you add 1 to minus 4 plus add to 0, so you get minus 3. And then you repeat the same step for multiplying up. Multiplying up, what you do is you start from the bottom and go up diagonally 3 times. So in this case, I'm going to start here and going up. Minus 1, 1, 3, I get minus 3. Minus 1, 2, 1, I get minus 2. And 1, 0, 2, I get 0. Alright, and same drill. We got 3 numbers, we'll add them together and call that up. So up going to be minus 3, minus 2, plus 0. And what's the final answer? The final answer is you just do whatever you get from down, subtracted by whatever you get from up. In this case, it's going to be minus 3 minus minus 5. So determinant is down minus up, which is minus 3 minus minus 5. So minus 3 plus 5, which is plus 2. So let me slow down and say that this is the part that people make a lot of mistakes because determinant has a lot of sign presented, right? When you have a minus sign, you will be multiplying a lot of minus sign to another minus sign. On top of that, you have to add them and then you subtract this another minus sign at the end, right? There's going to be a lot of minus sign going on. So this is one place that it's worth going back and double check your work because mistake can be made easily. Alright, now that we know definition or formula for determinant for 3x3 matrix, now we can define what a cross product of 2 vectors is. Cross product of 2 vectors can be defined as a determinant of a certain matrix. If I have V and W being V1, V2, V3, and W1, W2, and W3, you cross them, you get the following. notation for cross product is the x sign between v and w, and the result is determinant of this matrix. So it's going to be 3 by 3. The first row, we're just going to put ijk in there. The second row, you just copy entries from vector v. And last row will be entry from vector w. Alright, for example, if you have these two vectors, cross product between them follow this formula. So cross product between two vectors will be determinant of a matrix with ijk on top, 1, 3, minus 1 in the second row, and 1, minus 1, minus 2 in the last row. Alright, so just a quick reminder, vector I is nothing but vector that has 1 in the first entry and 0 in the rest. J and K has the same flavor, but just move the 1 over to the next entry. So how do we compute determinant? Well, first we repeat the first two columns. So in this case, it's going to be I11 and J3 minus 1. Then you multiply down, add them together, multiply up, add them together, then you subtract them. Down going to be, first cell going to be I times 3 times minus 2, so minus 6I minus J minus K, right? That's the down. For the up, it will be 1, 3K minus 1 minus 1I, so plus I, minus 2 plus 1J, so minus 2J. And again, to compute determinant or cross product in this case, we do down minus up. And then we just collect the term that has the same base vector together. For example, this guy has minus 6I, this guy has minus I. So in total, we have minus 7I. For the J, we have minus J plus 2J minus K minus 3K. So the answer is minus 7I plus J minus 4K. And if you want to make this vector look like original vectors, then you can just pull out minus 7, 1, minus 4 and put them in parentheses. So this is your answer. Alright, so some properties of cross product. Let's recall back to dot product. When you have two vectors, you dot them together. It doesn't matter which order you dot them, A dot B, B dot A, they will give you the same answer. Unfortunately, that's not the case for cross product. In fact, if you switch the order of cross product, the sign will go the opposite direction. So V cross W and W cross V are not the same. Actually, V cross W and W cross V will be the same vector but point to different directions. So commutative property is not the case for cross product. Fortunately, distributive is still the same. If you cross a vector to a vector that is a sum of other two vectors, it's the same as you cross each of them first and then you add them later. Those are two nice properties of cross product. But the most important property of cross product is the following. So when you cross V to W, the important property of the result is it turns out to be a vector that's perpendicular to both V and W. Alright, so one question that can be asked is find a unit vector that's perpendicular to 1, 2, 3, and 3, 2, 1. Alright, so this kind of question consists of two steps. First, we will be finding a vector, not necessarily a unit vector, but it has to be perpendicular to these two. And from that, we're going to find a unit vector based on the first vector defined. Alright, and if you want to find a vector, any vector that's perpendicular to these two, you just do cross product. To compute cross product, again, you compute determinant of these two, which I'll do it quickly. Just something like this. right? Minus 4i plus 8j minus 4k, which can be rewritten as minus 4, 8 minus 4. So what's the conclusion? Conclusion is this is a vector that perpendicular to these two vectors. Of course, there are infinitely many vectors that perpendicular to two given vectors. So even though this is a vector that perpendicular to both this guy and this guy, this is not quite the answer that we want because we want a unit vector. And this is clearly not a unit vector. But what we can do is we can find a vector that points to the same direction but has a unit length. And we use the fact that we introduced last time. A unit vector that points to the same direction as this vector is just this vector scalar multiplied by 1 over its size, which is something like, which after long tedious computation, this guy becomes 4 square root 6. So this could be your final answer, but if you want to simplify it further, it becomes minus 1 over root 6, 2 over root 6, minus 1 over root 6. Alright, and that's the end of the cross product. Next time we will be going over plane equation, which pretty much main application of how to use cross product. Right, that's the end for today. Thank you.